Ladies and gentlemen, the shaded area of this figure is 2 square root of 51 square units. Fascinating. Let's prove it. First of all, as always, let's go ahead and subscribe. Alright? Let's go.
How to tag?
This rectangle. Alright. So let's give names to the sides. Notice that inside this rectangle we have several triangles, and we want of this triangle that is in the center. So what we're going to do is name the sides of the triangles. But there are coincidences, right? This side is coincidentally the side of the rectangle. And this side here is coincidentally also another side of the rectangle.
Let's call this side
of this triangle and this rectangle.
Kidney
side
stone.
A, great. Okay, so now we will call this side side B. From here to here we will call it side C, and from here
all the way down
side D. Alright, from here to here side E, and from here to here side F. Perfect. And at this point you must be saying, but there are too many variables. And well, you're right. So let's reduce the number of variables. Let's remove this D and say that here, this little piece here, it's A, because this whole side measures A, and this whole side should also measure A. So a minus C is this little piece we have here. Okay, perfect. Now this little piece here would be B, which measures all of this minus this little piece that measures F. So this is going to be BC. Great, now we have fewer variables, and let's continue. We also know that the area of a triangle, look, the area of a triangle is base times height divided by 2. Thank you very much for the height. Perfect. And we can move this 2 to the other side, right? And we would have that 2 times the area of a triangle. It is equal to base times height. Great. So we can replace data here. Keep replacing data with the data we already have. So let's start with this triangle here. Just see the curve. Twice the area of this triangle, which is 6, 2 times 6, it's going to be equal to base times height. Any of these two can be the base, any the height, because it's a right triangle, right? Here it's 90 degrees, since this is a rectangle here. Alright, so let's say A times F, A times F or F times A, it doesn't matter. Multiplying F by A or A by F is the same. So we would get 12, which is equal to A times F or AE. Alright, let's keep it in order. First, let's put A, E, G, and A, and then let's put the 12.
Magnificent.
We already have
it?
here
Well,
the value of, and we will do the same with the other 2 triangles. So pay close attention. We'll have 2 again for the area of the triangle, but now it's not going to be 6,
if no,
but 0, 5. So 2 times 5 is going to be equal to base times height. In this case, B times C or C times B. We can write it as C, unless sinus C. So B, then C times B or CB will be equal to 5 times 2 or 2 times 5, which gives us 10. Awesome. Very well. Let's continue with the third triangle, this triangle right here. And let's say that 2. Stanemasi multiplied by the area of the triangle, which is 7. It's going to be the same as base times height. Either one can be the base or the height. And we had said that. So let's write it a bit more to the left. So we have space. 2 times 7 is going to be open parenthesis a minus C as C multiplied by BF. B minus F. Great. And now we have here 14. 7 times 2 is 14. And here we apply the distributive property. A times B gives us AB, then A times minus F gives us minus AF, then minus C times B gives us minus CB, and C times F. Minus times minus is plus, and C times F is EF. Alright, and pay close attention to what we have here. AF and CB, we already have that here. Look at this over here. AF and CB we already have. So we can replace it here, and we're going to have that 14 is going to be equal to AB. Very good. Minus IF is 12, minus CB is 10, and more selfies. Very well. And let's continue. We have 14 equals AB and minus 12, and minus 10 is minus 22. and plus CF. Okay, and moving this minus 22 to the other side, we get 36. Or well, let's do it here. Let's leave it here. 14 plus 22, which is going to be equal to A more CF, and then we're left with 36. Not 14 more 22 gives us 36, which is going to be equal to AB plus CS. Goodbye. Alright, now we'll replace here C and F, but with how? Let's get it out of here. Look, we can clear 2, or we can solve for F. So what's better here? Well, solve for F, and from here it's convenient to clear it up first. Let's clear it up. Let's write down the rest, and 36 will be equal A. C, instead of C we will then put, so solving from here we get, the 10, yes, 10 over B, and we note B here. So instead of putting C, we put 10 over B. Very good. 10 over B. And here, instead of putting F, notice that C is multiplied by F. We will isolate F from this. Let's isolate it. It gives us a 12 over A. Very well. It's a 12 over A. Great. And what do we have here? Well, up here, we have a times B, or B times A, and down here also B times A. Very well. And let's see what happens now. So what do we get? We get 36, which is going to be equal to AB plus 10 times 12 gives us 120, and all this about B by A or A by B, we'll write it as AB since here it's written as AB. Alright, now to get rid of this denominator, we're going to multiply the whole equation by AB. Alright, AB times 36 gives us 36 AB. And there'll be where AB multiplied by AB is AB squared. But not everything squared and more is nanas nas. Basta dana be multiplied by 120. Over AB just gives us 120. But we will do it step by step. So you can see it like this. 120 over AB. So what happens here? This simplifies with this, and we only have 120 left. Let's write it here as 120. Alright, and now we're going to move this 36AB to the right side. The left side will be 0, and the right side will be AB. All this squared was, it is, plus 120. But first, let's write this term, 36AB. Remember that when it moves to the other side, it becomes negative. And plus 120, ladies and gentlemen, tell me what this reminds you of. This is a quadratic equation. If we consider AB as a single number, which we can, because let's say A were 1, or let's say A was 2 and B was 3, well, this gives us 6. So 6 would represent X. Yes, if all these were X, it would be X squared minus 36X and plus 120. So we can replace or make a variable change, and we're going to say, ladies and gentlemen, that AB will be equal to X. So let's replace here. Instead of putting V, we put X squared minus 36. Instead of AB, we write X. And plus 120. Alright, and now see if it looks clearer that this is a quadratic equation that we can solve with the general formula. No. So we are going to apply the general formula. So let's note the general formula here. Remember, x1 is going to be equal to minus b plus or minus the square root b squared minus 4ac, and all of this over 2. Alright, and what about a, b, and c? Well, they are the numbers that accompany these letters, right? The coefficients then is the term that accompanies x squared, which in this case is 1. B is going to be the term that accompanies x, which in this case is negative 36. And in this case is going to be the constant term that leads us to x, which is 120. No. Let's erase all this to make room to continue. Let's erase quickly. Alright, if you're enjoying the video, don't forget to comment and give it a like. Alright, let's continue. We have x1 to the which is going to be equal to b, but b is 36. So we have here minus 36, more or less the square root. We are going to leave it open. B squared, which is negative 36. So we would have negative 36 squared. Sa, ika, just minus 4 times a. And it has I is 1 and C is 120. So 1 times 120, amazing. All of this inside the root and all of this here, notice, over 2a, but a is equal to a very... Alright, so we have x12 is going to be equal, minus times minus is plus, we get positive 36. Then we have approximately the square root of 36 squared. This 36 squared will give us a positive number. And why does it go negative? Well, it becomes positive when squared. So, considering that, we can write this here as 36 just as simply 36 squared. How do you write 36 squared as 9 times 4? Am I right or am I right? And all this squared. And you will see why I am doing this. I am doing it to simplify the root. So, not anymore. I'm not writing this 1 down because 1 multiplied by any number is just that number. I'll write down the 4 and multiply by 120. I can write 120 with like 4 times 30. So 4 times 30 gives me 120. Very good. And all this over 2. Alright, awesome. Here we have x12, which is going to be equal to 36 plus or minus. And here, notice that we can distribute this 2 to each term. So we would have here 9 squared, and then this 4 also squared. So 4 squared. But we know that 4 squared is 16. Very well. Okay. Here we have 4 times 4, which is also 16. Very good. And here we have times 30. Great. Look, we have 16 here and 16 here. That's very convenient. All of this over 2. Good. Now what comes next? We have times 1. 1.2. Which is going to be equal to 36 plus or minus the square root, factoring out 16. See for yourselves. So within the parentheses, 9 squared is 81 minus this 1.2. 30 from here. Alright, look. 16 times 81 gives us this here, and 16 times 30 gives us this one here. So the common factor is correct. And here we divide by 2. Remember that we can divide this 2 for each term. We can leave it here, over this one here, over 36, under 36, and under this root here. And we can take the square root of 16. Ladies and gentlemen, that was the purpose. x1, 2 is going to be 36 divided by 2, which gives us 18 plus or minus the square root of 16, which is 4. And inside the root, we'll have that. Look, 81 minus 30 gives us 51. And all this inside the square root and over 2, we simplify here. Half of 1 and half of 2. Ladies and gentlemen, this is what we have obtained. So, we found that x12 is equal to 18 plus or minus 2 times the square root of 51. We have reduced this here to this. Isn't it amazing? Let's erase this here and also the rest, so we can continue. Let's erase quickly. Alright, and here we have the 2 solutions, which we'll note over here as solution number 1, 18 plus 12 times the square root of 51, and solution number 2, which is 18 minus twice the square root of 51. Alright, let's erase this from here, and we're going to remember. You will go back to the video and remember that we had the variable change here. The variable change, ladies and gentlemen, was that AB is going to be equals X. That's how we changed it. So this here is no longer S1 or X2, but AB. So we have an AB here, and here also AB. Alright, so what is this here? This here, ladies and gentlemen, is the area of the entire rectangle. Why? Because the rectangle has side B and... this side is one side of the rectangle and this is the other side of the rectangle. So B times A or A times B is the area of the rectangle. And here we have the area of the rectangle, and check out solution number 2, which is this one here. Das heißt, wir sind in einer CLC Sinas Look, 18 minus 2 square root is 51. This couldn't be the solution for the rectangle. Why? Because only the sum of all these areas here already gives us 18. So, it couldn't be that the area of the rectangle is less than 18. Because here we still have another area which is the one in blue. That's the so this couldn't be the solution. So it can only be this one. The solution for the area of the rectangle, not the solution for the axis of the column. Now we're going to write the solution to the exercise. The shaded area is going to be equal to the area of the whole rectangle. Notice the area of the rectangle less than minus the area of all these right triangles minus the area of this triangle, this one and this one, so minus 5, minus 6 and minus 5. Number 7. Very well, the shaded area is going to be equal to the area of the rectangle, which is this one here. 18 plus 2 times the square root of 51, especially not this here. So a minus 5 minus 6 is minus 11 and minus 7 is minus 18. Okay, and pay close attention. 18 over here and minus 18 over there. What does that give us? Ladies and gentlemen, the shaded area is equal to 2 times the square root of 50. Square units as we predicted here. Fascinating. Let me know in the comments if you like the video. Bye, say